Yeah, I hope I'm audible and you're able to see my presentation, right?
Yes, sir. Yes, sir.
Okay, okay. Thank you.
Yeah, good. Yeah, please, sir.
Thank you, sir. So before I start, I just wanted to kind of understand the participants here. Are they mostly from the institutions, or are there any someone from the industry also present?
Majority are from the institutions. Majority
Okay.
are from the institutions, and few are from the industry.
Great.
And
Okay.
title is Energy Conservation and Audit title for this STTP. It is a short-term training program. Please.
Okay, okay. I just wanted to kind of know like how much basic should I go to? There are students also, I suppose, right?
Okay. Yeah.
Okay, okay, okay. Got it, got it. Fine, sir. Yeah, I'm just hiding what was not required. Yeah. So my presentation agenda for today, basically, it involves. I've just broken the discussion in 5 different areas. One is obviously on the importance of energy efficiency and why energy efficiency is required for the industrial segment. So I'm just focusing on the manufacturing sector and industries, and maybe a little bit. I may also cover a few things on buildings too, on the commercial sector. Also, the second aspect will cover the manufacturing sector per se in India, like what are the trends and the various technology options that are available for implementation of energy efficiency measures. The third part will cover the Perform Achieve Trade scheme for the manufacturing sector, which is part of the Bureau of Energy Efficiency. So I'll just throw a brief on what is happening on that front, and also maybe a little bit on what are the various schemes from the Bureau of Energy Efficiency that is being undertaken in India. The fourth part will cover ESCOs and financial instruments markets. So this will include what are the issues faced by industries in terms of financing or funding if they are not able to implement certain things on their own because of funding issues. And the last part will cover real-time data analytics and future technologies that are in the pipeline in terms of what India is looking for, and also probably the world is looking for in terms of the way forward. So this is how it is structured. So in case anyone has any questions, you can stop me in between, no issues, and can ask. So energy efficiency, we all know that anyway, all of you are aware of the importance of energy efficiency. And recently we found that, this is more relevant post-COVID era. That's because a lot of industries are facing issues, have faced issues in terms of not able to, produce goods, but still they are consuming, the energy has not reduced too much, even though the production is low, because they have to run certain equipments on a continuous basis to, kind of sustain it. For example, in a building, even though there is no occupancy, even though there are, say, a few people, anyway, they have to run the chillers at a part load, at a little bit of load, which may not, equated to the reduction of energy with respect to the occupancy rate. So that is why the specific energy consumption they find is increasing post-COVID, even though the production is increased. So I'll explain in detail about what specific energy consumption is and what are the energy benchmarking and trends that are available. So considering energy efficiency, we find that it is it's financially attractive for any industry or an organization to reduce their costs because energy costs, accommodate for a major portion of the overall production cost itself. Right. So That is one important thing that they are looking at. And sometimes energy efficiency is also termed as first fuel, because whenever you go for any expansion or other things, if you're going in for new systems, you try to kind of optimize your existing buildings or existing assets or your equipments, and then you go for further expansion, and that is where you kind of tend to uh, you know improve upon your existing performance of your equipment. The second one is obviously it reduces the energy bills. Other than reducing the energy bills, it also facilitates tariff reforms, because the tariff is different for different industries. For commercial buildings, whether it's MSMEs or big buildings. Uh, Again, it is based on, in some states it's based on KVA billing, in some states it's based on kilowatt hour, and there's power factor penalties or benefits which are given for improving your power quality and consumption levels. It also eases pressures on the national budgets. So my presentation would cover mostly from an overall perspective of India and what has India committed to the world in terms of carbon reduction. So that will be kind of linked, and that's where I say that it eases pressure on the national budgets, because whatever national the laws or reforms that are taking place depends on various aspects of on how the industry performs, and because of that, certain budgeting aspects are being taken care on that level. It also increases competitiveness of industries, right, and services. It also creates a lot of jobs, because right now you see the energy efficiency market itself has produced a lot of jobs for people. Probably you'd be aware of energy managers and energy auditors who should be there in every industry. That's a mandate that an energy manager has to be recruited and placed in any organization which is considered as a designated consumer from the Bureau of Energy Efficiency. And also, in terms of benchmarking, one industry, will look at other industry and how they are performing and try to improve upon them. It also improves system reliability by reducing the energy demand and peak load. So whenever there's a reduction in consumption levels, say if an industrial area has say 100 industries, and each of them are able to reduce a little bit of load because of energy efficiency, the overall peak load reduces in the grid itself for that particular feeder. Now, because of that, the grid releases itself, and they're able to perform better. There are no congestions that are happening. So that's where the peak load management is one other aspect that people are looking at right now in collaboration with energy efficiency. Now, it is quicker to implement than many supply options. Now, we have two things here. One is whenever there's a demand increase or there's an increase in load at the end use point or with the customers, either they have to get more power from the grid or they have to consume more fuel, or the other option is reduce their consumption itself so that their demand reduces. So instead of increasing the supply, they are able to kind of reduce their demand, which helps them, and also the overall subsystem itself to be effectively engaged or better. It contributes to reduction in greenhouse gases and local emissions. So that is a given here, and also there's a cross-sectoral benefits also because of energy efficiency. It not only improves your the consumption levels, or it helps in helps in reducing the consumption of that particular organization, but it also helps in health aspects. For example, GHG and local emissions. Sorry, local emissions are affect the health conditions of people. Water is another aspect where energy efficiency is related to water. There is something called energy water nexus, where pumping water, distribution of water, and also wastewater treatment plants are being made better, and it's able to provide better performance for remote areas. Urban development, we are talking about smart cities and smart grids. So even in the various other sectors, energy efficiency brings about the cross sectoral benefits per se. So on the right hand side, if you see, just I've explained most of the points. The source, which is from the International Energy Agency, in 2016, they said that energy efficiency improvement helps in all these aspects. So the one thing I didn't cover is on the macroeconomic impacts from overall world level. For example, every country has given something like an INDC, right? Intended nationally determined contribution in terms of what should be their reduction in CO2 emissions year after year. So it helps in disposable income, air pollution, employment, like poverty alleviation, where people get benefited because of these various aspects, and also the asset value. So any equipment that consumes power, right? So if it's able to kind of uh, run at a lower load, or an optimized loading condition, it helps in increasing the asset condition itself. For example, the last speaker spoke about the chillers and HVAC systems, where sometimes like it's kind of peaked up. Even the transformers are running at a very higher load. The motors are running at overloaded conditions. So these kind of things can be avoided. So I go to the next slide. Yeah. Uh, so here, this particular slide, talks about the overall energy consumption scenario in India. So so one thing you should understand is the energy consumption levels are notified in terms of MTOE, or million tons of oil equivalent. So when we say MTOE, the consumption would be at different levels and with various fuels. For example, an industry would source electricity from the grid, or from different private players, including renewable sources of energy, for example, solar or wind farms. The other is they'll have their own fuel consumption. Some of them will have, for example, furnace oil, or diesel for their diesel generators. There may be others using naphtha and various other aspects, especially in refineries. There's a lot of fuels which they use. So to kind of come to a common platform, all sources of energy are converted to million tons of oil equivalent, and that is how it is being given in all over the world. So here, if you see India's primary energy consumption is right now, it's about the third largest in the world, probably after America and China. So it accounts for about 553 million tons of oil equivalent, and out of this, about 56% share of the energy consumption, which is about 307 million tons of oil equivalent, is in the industrial segment. And when you see industrial segment, we have major industries and minor industries. I'll go through those in detail. But MSME, or the medium and small scale industries, they account for about 68 million tons of oil equivalent, which is about 20 to 25% of the total industrial energy consumption. So this is one area where there's a lot of efforts being put, because the MSMEs are not very much aware of the energy efficiency. The big industries are aware, and they have been mandated by the government to reduce their consumption. But for the MSME sector, there's a lot of support that is required, and that is where we are talking about innovative financial mechanisms, like partial risk guarantee funds, which are required by the MSMEs. That I'll be talking later on. So, as per the BA National Strategy Plan, now industrial sector, they have about 60% saving potential. Actually, by 2030, they'll be able to reduce, or the saving potential, they can reduce it by about 47.5 million tons of oil equivalent. So just a small background about the transition of energy efficiency in India. So this is basically from the ESL presentation. So where pre 2001. So it started from about 1970 70s onwards, which could be considered as the pre-EC Act era. So Energy Conservation Act, it came in 2001. So before that, there was a lot of voluntary initiatives by the industry. So it was not mandated. So anything which is voluntary, so people who are interested would take it up. So there was a lot of awareness which were given, especially from organizations like National Productivity Council, TERI, Petroleum Conservation Research Association. So they were there right from the 1970s, and they were involved professionally with a lot of involvement with industries where they created awareness and made them to reduce their energy consumption. But what was the problem was it didn't relate to much impact on the energy overall energy intensity itself, and most of the savings were not at all reported. So because it was not mandated, most of the things were not reported, and there was no clarity on what has been implemented and what has been not. So from 2001 to 2008, what happened was the Energy Conservation Act came somewhere between 2001 2002, and B Bureau of Energy Efficiency was established in March 2002. And there were a lot of energy efficiency programs which were launched post 2006. Probably you would have heard of standards and labeling, perform achieve rate, a few other new schemes which are being launched. The motor efficiency studies, all these came after that, and the energy impact was felt after 2007, and there was a lot of savings being reported. There were organizations giving out awards for different companies, and there was a lot of documentation which were there in terms of what are the new energy efficiency measures or what projects can be implemented. Right. So post 2008, it was called NMEEE, or the National Mission on Enhanced Energy Efficiency. So there was a national action plan on climate change, which was formulated in June 2008. And under NAPCC, you have a National Mission on Enhanced Energy Efficiency. So the Energy Conservation Act was amended in 2010 with the launch of various other programs from 2011 onwards. And that is why a lot of impact was felt on intensity, and the national targets were being fixed for each of the industries to achieve. So what we see here is, in terms of reaching the sustainability goals, uh, you know, so India, as I said, they're committed that they'll reduce CO2 emissions by a certain percentage, and this is like all over the world. All the countries have committed. So when we're talking about sustainability, so energy efficiency is one part of overall sustainability goals, right? So any of the industries or major, big industries, they have something called a sustainability goal, which they report every year. On their targets and what they need to plan or implement to achieve those sustainability goals. So when you talk about sustainability, we talk about like what is their GHG accounting, carbon accounting scenarios, energy efficiency, how they are going to reduce their water, and the various things or material that they use for buildings or for various other aspects. How are they going to reduce the overall consumption, right from now we are talking about circular economy, where there's recycle, you don't consume and throw it away, but as much as possible try to use things. So when you consider all of these, right? So there is no single or simple solution to reach these sustainable energy goals. So what is required is a lot of policies and technologies which are needed to reach the targets. And a lot of new technology innovation is really essential. If you see this graph, so in terms of carbon dioxide, gigatons of carbon dioxide in 2010, it was somewhere in 30. And if the current trend continues without doing anything, it will go beyond 50. And when you have certain policies in place, we try to kind of reduce it by looking at all these aspects on the right hand side, right? So that is why you try to reduce the overall emission levels and bring it down to about say 10 gigatons of CO2 if you have all these. For example, if you just go and change industrial electric motors to IE3 motors, or probably IE4 in the near future, then you have a certain percentage of energy efficiency, and because of that, the CO2 emissions will reduce. You go for better and smart buildings. Then you have power and the light industry. So you have different industries where technologies are happening at various levels. Cars and trucks. Now we are talking about EV cars and EV charging stations. Heavy industry, air conditioners. There's a lot of things happening in the air conditioning industry in terms of reducing the IKW per TR, and overall consumption, how it could be reduced by being better and better. And a lot of automation are taking place in the aviation and shipping industry. There's wind, solar, which is being talked about a lot now. There's a lot of generation happening, and a lot of installations are being happening, especially on the solar front. Biofuels for transport. Then there's other renewable powers. End users have started generating on their own right now. Efficient hydro, nuclear, fuel switch, especially on hydrogen. There's a lot of activities which are happening. So in the near future, you'll find a lot of hydrogen related technologies which are coming in for implementation. uh, Electric vehicles and carbon sequestration. How you capture carbon and reduce it. So especially on the power industries, there's a lot of new technologies for emission contention, which is happening right now. But mostly, what is important is on the behavioral change and resource efficiency. Even though there's a lot of technologies come in, if, for example, if we don't switch off our light when we are not there, or not using, or switching off certain equipments which are not being used, right? That is basically, it comes down to individual behaviors, right? So that is where that's very important to have an overall impact. And other than energy, we talking about overall resource efficiency itself in terms of waste, water, uh, plastics, how they're being used, because there are a lot of industries which are talking about whatever product they are manufacturing, how is it related to the source? Like, for example, they will buy raw material from another organization, right, to finalize their product. So how is that organization, how are they sourcing that raw material? How is that organization, relating to, bringing about an impact? So this is where we are talking about, right from the initial source to end, or probably you can also call it as cradle to grave kind of a scenario for each equipment. Like if you have a pen, uh, we go back to different layers, right from where the plastic is being sourced, how is it manufactured, and how the pen is being disposed, and then what happens to the pen, like after that, what happens. And that is where once they started analyzing this, there's this concept of circular economy, where they felt that once it is kind of come to its end of life cycle, how are they going to recycle it, or reuse it in a better way? So that is what is required right now in terms of achieving the sustainability goals, and in terms of integrating various technologies that are available. So coming to the manufacturing sector, so I'll just give a broad classification of how the manufacturing sector is. This is like this is all over the world. Like this is a typical classification. So one is energy intensive manufacturing, right? So you need a lot of energy to produce all these products. For example, iron and steel, non-ferrous metals. This could include, something like copper, aluminum, zinc, refineries, pulp and paper, chemical industries, and non-metallic minerals like cement and glass, food and beverage, textile, sugar, tobacco. These consume a lot of energy, and that is why they are called as energy-intensive manufacturing sectors. And the Bureau of Energy Efficiency has targeted these type of industries for the perform achieve trade mechanism, where they fixed targets to each of these industries. The second classification is something called a non-energy intensive manufacturing. So it is not energy intensive. So this again, it relates to what is the energy costs percentage in terms of the overall production costs. So these non-manufacturing, non-energy intensive manufacturing industries include, pharma industries, paint coatings, adhesives, detergents, and metal-based durables. Now, when you say metal-based durables, anything which is related to metal, for example, any fabricated products, machinery, computer and electronics, transportation equipment, electrical equipments, assembly equipment, those kind of things. And then finally, you have non-manufacturing, which is also considered as a manufacturing sector right now. These non-manufacturing sectors include agriculture, forestry, fishing, mining, oil and gas exploration, heavy and civil engineering construction. So here you should be aware that mining, oil and gas exploration is very energy intensive, but because we are extracting sources of energy, it is right now classified as non-manufacturing. As per the International Energy Agency, some of the energy-intensive subsectors, right, these represent the major operating costs. I mean, energy accounts for a major operating cost of the overall, cost scenario. It needs a lot of support from government programs. The light industries, something like textile, food and beverage, and automotive industries also provide a lot of energy, significant opportunities for energy reduction. Yeah, so if you see the next slide, the manufacturing industry, as we saw in the first slide, it's being impacted. There's a lot of financial, challenges which are being faced post-COVID. So right now, the industrial sector is looking at various policy packages. Now there are three things which are required for an industry to survive and also bring about energy efficient manufacturing. So one is on the regulatory aspects, right? Creating a strong push for energy efficiency improvements. The second one is information. So information, when you say, they should be aware of what is happening with their neighboring similar kind of production process, as well as benchmarking norms for India as well as world. So when you talk about best practices, we need to look at what is the best thing we can do to produce at a reduced consumption level. And that is where BAT or the best available technology that is available in the industry right now has to be studied, and whether they are capable enough to implement these technologies based on the availability of funding. Right. The third one is incentives, creating a market for energy efficiency. So just like that, most of them may not, do anything to improve, because it may involve a lot of investments required. So they would think that probably we'll just wait for some more period of time and see, maybe at the end of life we'll think about replacing this particular equipment. So if there are certain incentives that are available and the payback is good, then it will create a market for energy efficiency itself. So funding opportunities for implementation of these measures for upgrades and process improvements are really required. So I'll cover that in the subsequent slides. If you see these four boxes, we already spoke about this in the previous slides. The energy efficiency potential, which is there, which is available right now, or not right now, it's for about 2031. We are looking at a total investment potential of about 8.4 lakh crore to bring about improved systems in place. And emissions in India's NDC targets, nationally determined contribution targets, right? So here, this is what we have committed in reducing the carbon emissions. So this is basically 36% reduction in emissions intensity by 2030. With about targets of about 30 to 35% is what India is looking at. Now, when you consider certain we spoke about the categories of industries. Now here, this again, the energy conservation guidelines from Bureau of Energy Efficiency. It talks about 5 different categories for industries. So that was an overall classification. But here, when you see category A industries, it covers all the designated consumers under the Perform Achieve Trade Scheme. So this includes all the major industrial sectors, which we already discussed, which are energy and intensive sectors. Now, category B industries are also large industries, which with energy consumption of slightly less existing minimum threshold levels for DCs. So when you say minimum threshold levels, the designated consumers are chosen based on their million tons of oil equivalent which is being consumed for producing a ton of their product. Now, if it is above a certain threshold limit, then they are classified as a designated consumer. So these industries which are slightly below that are classified as category B. And category C, from category C onwards, the small and medium scale enterprises, right? So they come in. So category C industries, they include small scale enterprises where the major source of their accounting has energy is as one of the major component, which accounts for about 30% of the total production cost. So these type of industries are typically like glass, foundry, forging, ceramics, dairy, and textile. Category D, which are medium enterprises with energy costs between 10 to 30% of the total production cost. So these includes small and medium industries like brick or hand tools, food, limestone, those kind of industries. And category E is basically very minor or micro industries, which whose material costs are very high than the energy cost. So their objective is not much there, or the potential itself is very less in terms of what energy efficiency improvements can be done in that particular sector. Yeah, let me just briefly go through the overall audit process or the process flow. Yeah. This is typically when we speak about industries, the first thing that they do is do an energy audit. Now, this energy audit or assessment can either be done in-house with their own people or their own team, probably the energy team, or they can get the help of external agencies which does an audit and gives them a report in terms of what are the measures that can be implemented to bring about change in their overall consumption levels. So the first thing that should be done is energy assessment preparation. So you have to kind of assess the scope and how you plan for achieving that scope documentation. For example, scope could be, maybe my calculating the energy efficiency or the efficiency of a boiler. Right. So how do you plan it? So you plan it by getting certain what are the equipment that needs to be done? What are the instrumentation that is already available? If instrumentation is not available, then do we measure it with some other instrument which we can take it, a remote kind of an instrument, or are there certain sensors that needs to be implemented, those kind of plans, and who will be doing it, who is the team. The other one is on the checklist of questionnaire preparation. So checklist will include what data needs to be collected, and what are the questions that needs to be asked on the shop floor to the operators, and what are the identification of the equipment instruments required for measurements. Then collecting energy bills and operational data. So when you consider the overall industry, so they'll be getting these energy bills. So energy bills is not only electricity from the grid, but it also involves a lot of other energy which is being used. So they may be using diesel or furnace oil, or various other, LPG maybe for some of their process equipments, especially on iron and steel industries. And on the operational data in terms of what are the operation, effective operations that are taking place. What is the running hours of that particular equipment? And in case of a boiler, do they have the pressure and temperature conditions which are available? Are they noting down in their logbooks? Those kind of things, and based on that, we do a preliminary analysis with energy indexes or energy consumption analysis or specific energy consumption (SEC). So you kind of pre-plan on what are the benchmarking that needs to be done for that particular industry or that equipment. Then the next thing is we carry out the execution of the energy assessment. So it'll be an initial walkthrough just to see the condition of the equipment. Go through so that once seeing, you'll be able to understand what is really happening in that particular industry or the set of equipments. Then we prepare the single line diagrams. The SLD single line diagram is not only related to electrical distribution, but also maybe the steam distribution. For example, the boiler will generate steam and supply to various processes, or it may go to the turbine to generate power. SLD could be also, the compressor air distribution within the industry, where it is being so distributed. What are the pressure levels at different condition at different areas, and then analyzing energy use patterns, and you do a benchmarking and comparative analysis. Then based on that, we identify what could be the energy efficiency potential which are available there. One example could be when you go and observe a boiler, you find that the insulation levels are not proper there. So that is one area of improvement. So then you target that area, you measure the surface temperatures to find out what are the losses that are happening there. And then to put in a new insulation, what is the investment required, and what is the payback? That comes under the cost benefit analysis. So then we kind of find out whether it is useful to improve, implement this particular project based on the payback periods or ease of implementation, various other things that are available. Then you report it out. So we do an energy report with recommendations, and post assessment would require, like, how do you plan to implement the recommendations. So that will also include a lot of detailed engineering design to come to a conclusion. And then even during the initial assessment phase, it may be feasible, but once we do a detailed engineering, we may find that it's not at all feasible at all. So in that case, that part will give an indication of whether to go forward or not. So these are some of the equipments that or the information that needs to be collected. It could be energy consumption by the type of energy, but department-wise. There are a lot of process equipments which are available, process department-wise and by end use. The other one is doing the material balance, right from raw materials to intermediate and final products, whether some of the materials are recycled back into the process, whether there are any scrap or waste materials, or there's a byproduct for use in other industries. So these have to be identified. So we have to get the energy cost and tariff data. material and process flow diagrams, generation and distribution of site services, right? So there we spoke about compressed gas steam. What are the sources of energy supply, whether they are self-generating on their own or they are taking electricity from the grid. Other could be what is the potential for fuel substitution, whether there's any thing that could be done, because some industries are say 30 years old and they'll be using some old equipment with fuel which is used at that point of time. But right now, new technologies are there with energy efficient, fuel systems. So those kind of things, substitutions and other things should be looked into. Cogeneration systems, whether it could be possible in terms of combined heat and power generation, and also energy management procedures which are already available within the plant. Do they have any systems in place, or it needs to be developed further? And also creating an awareness within the industry. Now, these are certain questions that needs to be asked for with the operating team to bring about a clarity in terms of what we are planning to do. It could be simple questions like what is the percentage of your operating costs in energy. So these are certain questions which you ask to the top management, and some questions for example, the equipment level basis you ask to the operators. So then you ask about like what is the energy costs, what are the kind of energy impacts of your capital projects. Has your company established an energy goal? Is there an energy team? What are the savings or identified projects, and whether you implemented any of those? Are you aware of inputs and outputs? Do you have an energy performance index for your company? So most of the time we find that there are other priorities. So some of the industries which are not looking at energy efficiency, the typical answers could be we have other priorities, like we are more interested in quality, safety, and production than energy efficiency. Sometimes energy is taken for granted there. They say that this equipment is working right now, so why should we fix it? Even though they don't realize that it consumes a lot of energy. The other one is about lack of data. Data is not in place, and it's narrowly focused. So the top management is not aware of what is happening at different sections or different departments of the plant, and they say you talk to some other team for that. The lack of awareness and insufficient resources, both finances and staff time, which are available to them. So that is where we identify that once we get into the process, doing a material and energy balance is really important in terms of achieving the purpose and objectives as you see in the slide. So you have to get the components of the material balance in place, like in all the material in, like raw material, chemicals, water, energy, power, recycled material, if any. Then the outputs could be, emissions, products, byproducts, wastewater, liquid waste, solid waste. So these we do in terms of what is the incoming in terms of kilograms or tons. So here we just consider the material in and material out. And then we consider the energy balance, like we do the MCP delta T calculation in terms of overall energy requirement itself, right from electricity, steam, all the water, energy and raw material, with various processes and unit operations. And then what is the output? So when we do a material and energy balance, automatically we will be able to kind of identify the losses which are available, and then come about to bring about recommendations there. So here for any industry, so this is typically a slide which talks about what are the possible areas that we can target for energy efficiency, for any group of industries. So instead of going into equipment level, here the Bureau of Energy Efficiency, they talk about, you look into the process itself, and from there you go about at the equipment level. For example, section 1, it says that, look at combustion of fuel. When you say combustion of fuel, obviously we have to look at equipments which are thermal consumers. For example, boiler, industrial furnace, and thermic fluid heaters. So here what is the fuel being used right now, and whether there's a possibility of reducing the present fuel consumption, or you can bring about a change in the fuel itself, or doing a fuel substitution. The second one is looking at, say, heating, cooling, and heat transfer. When you say heating, cooling, and heat transfer, it could be heating equipment, which is part of that too, or it could be air conditioning and hot water supply equipment, HVAC. The HVAC is not only looking at cooling system, but also on the hot water requirement. For example, in a pharma industry, you require hot water in the AHUs to maintain relative humidity. So these are the things that needs to be studied and identify and target those equipments where we can bring about an improvement. The third one is about waste heat recovery and usage. Now, when you say waste heat, any of the equipment would produce waste heat, and that efficiency, overall efficiency, can be improved if we can be able to use that waste heat and use it for some other process within the facility itself. Now you have different areas like boiler, condensate steam recovery, industrial furnaces, turbines, diesel engines, and thermic radiators. One example could be in a condensate recovery system. You generate steam. Steam goes to a process heating requirement, and then it is not being reused, or it is not pumped back to the boiler. It is being drained, right? So that is a loss, and that is where you tend to improve the overall efficiency of the heating system itself. The other one is conversion of heat to electricity. Right. So when you say heat to electricity, we are talking about power generation facilities and cogeneration facilities. So any of the gas turbines or boilers, steam turbines, and diesel engines convert heat to electricity. So you generate steam from a boiler and use that steam to run a steam turbine and generate electricity. So you, for example, you use coal in the boiler, you use that heat energy in that coal to generate electricity. So this overall conversion, we find out what are the losses that are available and try to minimize those losses. Then there's prevention of energy loss due to heat radiation and electrical resistance. So here, in an overall scenario, we're just talking about insulation requirements either for electrical systems. It could be for motors also, and also for the thermal systems, which includes steam distribution systems or condensate distribution systems, where you have a lot of heat content, but that is being wasted. The sixth point is about conversion of electricity to motive power, like power, heat, and light. So here we are talking about lighting systems where you convert electricity to provide light to systems. It could be compressors which will provide process requirements. Industrial fans and blowers which use electricity to provide various air for various processes, cooling towers and transformers. So these are the electricity-driven equipments that are available in any of the industries that needs to be targeted. The final point is about industrial energy management system. So here we are talking about how you kind of improve the overall plant energy management, be it through IoT-based systems, or it could be by setting up energy performance indices, and you tend to bring about an improvement there. So these seven sections would cover almost all the areas or all the equipments that are available in a plant system. So this I wouldn't go into much of detailing because these are certain technology options that are available. For example, for large industries, you have waste heat recovery, drives for pumps and fans, boiler optimization, combined heat and power, and pumps and fan optimization. Whereas from an MSME perspective, most of the opportunities would be in compressor optimization, power optimization through improvement in power factors and demand controllers, heat pumps, and again drive controls and chilled water optimization. So this is basically certain technologies which they have evaluated for ESCO programs, which are scalable, so that more and more industries can implement these on a larger perspective. So the bottom slide just talks about what are the investment levels that are required at the typical payback period. So here, if you see anything which ranges from about 0 to 3 years payback is what is being seen, and any of the institutions which give funding would look at giving providing funding for any technologies which are less than 3 years payback to be on the safer side. So typically this is on the medium and small scale industrial segments where certain studies show that technologies like waste heat recovery, you have a saving potential about 26%, with a replicable potential about 30% here. So likewise, these are general energy conservation measures that can be used for any like optimization of boilers and steam systems, motor efficiency and rewinding for smaller industries, fuel switch, electrical energy efficient lighting systems, pumping systems, insulation, efficient compressors, and VFDs. So these are certain technologies which are very easy to implement. These are proven technologies that can be taken up by any of the financial institutions for funding, and that is the objective of this particular slide. So this is also most of the things that are already covered. Just listed down certain potential energy efficiency measures for any industry. Uh, one example I could give in terms of energy management approach. For example, if you consider a cement plant, right? So here there are three aspects to it. One is we just look at energy conservation measures from a utility system study perspective, controls optimization, and heat balance and efficiency related. And what are the equipments that you need to target for each of these areas? So here we talk about the general energy efficiency assessment. Either the plant people do it, or from an external agency to find out what are the potential which is available in that particular equipment. The second one is looking at monitoring and controls deployment. Now there we are talking about monitoring system. So one is on the efficiency, but for arriving at an efficiency, we need sensors in place. Or if sensors are not there, certain equipment should be there for measuring, right? For example, pressure, temperature, flow monitoring, cold flow, raw material flow, or distribution of energy within. The other one is on a set point policy perspective. What are the temperature of set points? What are the cold flow set points? What happens if it goes above or below this set point? How are we going to kind of monitor the minimum maximum conditions? What happens if it goes beyond a particular set point? Those kind of things needs to be evaluated there. And the last one is on the controls aspect, like what are the controls that needs to be done to move that particular parameter within that range, and that is where a lot of automation is required. The third one is retrofit and technology related options, which there are a lot of new technologies which are available. For example, in a cement plant, we are talking about efficient preheaters and cyclones, high efficiency separators, energy efficient blowers and refractoriness. There's a lot of potential existing in waste heat recovery from coolers, preheaters, slag dryers, and boilers. And technological options, which are, we're talking about efficient material conveying itself. For example, the cement or coal, which is being taken through conveyor belts. Those are, there's better material in place with less friction losses. Those kind of things can be talked about for implementation. Here again, whatever we do, if the management, the top management support is not there, then there'll be an issue, right? So here, if you see, this is a cyclical kind of way that most of the organizations have. So whenever the cost goes high, they say, let's do an audit. Then they do some, cutting some investment is being done, some energy efficiency measures are being identified, implemented. Then finally it comes to control. But after some time, costs again increase. Then that is where they said the management will ask, like, when was the last audit done? And then they start doing it again. And this is how it is kind of done for most of the industries right now. So in alternative to that, if the senior management has a program in place, uh, how do you sustain the savings that you already got at the initial level, right? So that is where the senior management should push for the team to kind of sustain it, improve the housekeeping first, and then you bring about improvements, bring about investments. So here in the industry, they talk about getting the low hanging fruits first. So you get those things in place, and finally energy efficiency should be a company culture, and that is where you tend to reduce your the overall costs. So with this I just conclude the general aspects to it. If there are any questions, I'll answer. Otherwise I'll go to the next topic of performance trade.
At last, we'll take questions. I think.
Yeah, sure. Thank you.
That would be better. Thank you.
As we discussed previously, there is something called National Action Plan on Climate Change from the government. There are 8 missions under the NAPCC. Right. So here we are talking about National Solar Mission. It could be for Knowledge Strategic Mission, National Mission for Strategic Knowledge for Climate Change. There's a mission for Sustainable Agriculture for Green India, also to sustain the Himalayan ecosystem. There's a National Water Mission and a mission for Sustainable Habitat. And one of the missions under NAPCC is called the National Mission for Enhanced Energy Efficiency, or NMEEE. Now, under NMEEE, we have 4 major buckets where the government is pushing for energy efficiency, and perform achieve trade comes under this mission. So this part is for the energy intensive industries that we already spoke about, and there are targets for mandatory energy savings. So this is one part of it, and for the other one is EFP, or energy efficiency, funding programs, which is basically to stimulate funding for ESCOs. So I'll come to the definition of ESCOs later. So ESCOs are basically, just to go a brief, these are organizations that take up the responsibility and guarantee to implement the projects on the customer's behalf. So there are certain funding options which are available for ESCOs. The other one is the market transformation for energy efficiency. So here you would have heard of energy efficiency appliances like standards and labeling. And demand side management kind of products. So you transform the market. For example, this 5-star labeling that you see in any of your heaters and refrigerators, these come under this particular mission. And then you have fiscal instrument for energy efficiency, which is again part of various instruments for bringing about an overall policy change, including financial options. So under the regulatory framework for the perform achieve trade, so this is already mentioned in the Energy Conservation Act, which said that you have to provide norms for energy efficiency industries, and also bring about certification of energy professionals there. So PAT is a market-based regulatory instrument to reduce SAC norms for the industry. So this will bring about very cost effectiveness, and also a market-based mechanism where they are able to trade energy saving certificates within the industry. So this is a part of the overall INDC policy objectives that we discussed previously. So here, if you see, this is basically a regulatory mechanism to incentivize energy savings. So under the scheme, the designated consumers have to reduce their consumption in a 3-year cycle, and anyone who's achieving the target will be issued energy saving certificates, and those not achieving the targets would be paying a penalty. So that's how the thing works. So typically the PAT 1 cycle started in 2012, and it was for a year. Then the assessment, this is basically the assessment year 2018, 19, and 19, 20. So prior to that, 3 years before, they have to do the energy conservation measures with a baseline period considered. So here, right now, we are talking about, right now we are in the PAT 6 cycle. These are the energy saving targets which are there for the number of designated consumers that have already been identified. So when you consider the target fixing by the government, they fix the targets based on gate-to-gate approach. When you say gate-to-gate, any plant boundary or industrial boundary is considered as a gate-to-gate. So within that gate, what are the various forms of energy which comes in is considered as E, and what is the product that goes out of the factory is considered as P. Now there will be certain byproducts that are being consumed within the facility itself, so that is not being considered. So the specific energy consumption is defined as E by P, or what is the energy consumption in terms of when you convert it to million tons of oil equivalent per ton of product. And that is where they fix the baseline SEC and the target SECs, which they have to achieve in year 3. And the reduction in SEC is expressed in certain percentage. So this is the PAT evolution right from 2001. This we already mentioned in the previous slides. So from 2008, 17, 18, PAT 3 was notified, and right now we are under PAT 6 cycle. So this is the concept of the target and compliance. So if you see this blue bar, that's the baseline specific energy consumption, and the target is fixed. So that means they have to achieve the saving target. In case they achieve the target, they don't get anything, right? If there's zero achieved SEC. But if they're able to reduce it further than the target SEC, they'll be issued energy saving certificates. Say scenario 1 is the issuance of ESERTs. Now, because in scenario 2, if they are not able to achieve the target, even though they reduce their consumption from the baseline SEC, but not able to achieve the target, they can buy that particular area from another organization by paying some amount of money, because this will be the ESERT value will be fixed based on the market demand conditions. And still, if they are not able to achieve that, even after they buy, then for the remaining portion, they have to pay a penalty to the government. So energy saving certificates are basically one ESERT is equal to one MTOE, and there's a penalty for not meeting the targets. The ESERTs can be traded. Now, if an organization has to buy ESERTs, they can do it, or if an organization has to sell it, they can do it through IEX or PXIL, Power Exchange or Indian Energy Exchange. So this is the same thing. How it could be achieved, whether it's issued or not issued. So non-compliance is basically when they are not able to achieve it, and they are not able to buy a ESERT certificate from the market. Then they have to pay a penalty to the government. So as I mentioned, under PAT 3 and 4, these are the industries which have been selected under the scheme, and out of this, each have a list of DCs which are already there. So you have cement, iron and steel, textile, aluminium, pulp and paper, chloralkali, fertilizer, and refinery from the industrial perspective. From thermal power plant, it's basically coal-based and gas-based. Railways, discom and building came into existence later, and right now these are new industrial segments which are there, both from a discom and a hotel perspective. So under each of these industries, there are different subsectors which are also covered. This right now we are in the PAT 6 cycle, as I mentioned. So 2022-23 is the year of assessment. So these are the number of industries which have been identified in addition to the previous industries. And so year on year, when you have new additions, you tend to kind of bring about more consumption level reduction, which benefits the government, that they can claim as what they've reduced overall from an India perspective. Just to do a brief of how it happens, the rolling cycle happens. Now, if you have, say, 2016, if you are an industry on the PAT 2 cycle, that means they have 3 years to implement it, right? So you have 1, 2, 3, and then in the next PAT 6 cycle, their next target starts. So PAT 3, the industries on the PAT 3, their next cycle would be PAT 7. So this is a kind of rolling cycle that will happen year on year. And every year there'll be new industries which are being targeted for designated consumer list. So that means that the targets would be reduced, or the specific energy consumption norms would be kind of reduced to bring about more and more industries into the into the PAT cycle. So the typical path cycle will start with a baseline audit, then they'll do a target fixing, then they have to do a mandatory energy audit to identify energy conservation measures, then they do the implementation, and finally MNV is being considered. And then after 3 years, once that is done, a revised baseline is done and a revised target is being fixed. And that is how they kind of keep on reducing their overall targets so that the final target is reached. So it doesn't mean that it will keep on reducing. Energy efficient units will have lesser targets, and less energy efficient units will have higher targets. So that's how it is being fixed right now. The next portion is about ESCOs and financial instruments that we discussed. So when you're talking about implementing these, a lot of these large energy intensive industries are big players in the market, right? So they have their own funding options. So they are capital intensive, and they have good capex for energy efficiency schemes. But there are certain industries which may not have funding with them. Or the other option is they don't want to take the risk of implementation. If something goes wrong, then what happens? Because they're not aware of whether this technology will pay benefits or not. And that is where ESCOs come in. So ESCOs are organizations that will offer both technical and financial services to implement these kind of projects. And they guarantee these projects to cover a period of time, maybe 5 years or 7 years. So what are the offerings is basically they help in identification and developing and also designing these projects. They acquire financing from third-party financial institutions. They also help in installing these energy efficient technologies and also do measurement, monitoring and verification of savings. And they'll get a certain percentage of the savings out of the final savings that you get. Suppose your consumption is about say 100 rupees is your energy bill, and they're able to they're able to save 20 rupees in their overall energy bill, and you tend to pay 80 rupees, and from the 20 that'll be split between the ESCO and the end use customer. And out of that split that ESCOs get, they will pay use that money to repay the interest percentage and other aspects and the project management costs. So this is where the ESCO will pay for the project. It's not that the customer has to pay. The ESCO would arrange for the funding, and ESCO will pay for the project. The improvements in energy efficiency will bring about savings, and the savings will repay the ESCO. So this is how the technology or the system works. And sure, we have different models which are available in the market, like shared saving model and guaranteed saving models. So from a shared saving perspective, the ESCO would implement. And the financial institution will give the money to the ESCO, and they will use that to bring about the energy efficiency for the end use consumer. From a guaranteed saving perspective, the financial institution will give funding directly to the end use customer or the industry, and the ESCO will only facilitate the implementation by giving a guarantee that this will be the kind of savings that you will achieve. So ESCOs basically why consumers are looking at ESCOs or not able to implement energy efficiency projects is because it could be either lack of technical ability. There'll be a limited financial limitation. They will not have money to implement. They'll not have time to focus, or the transaction cost could be higher, and multiple stakeholders they don't want to manage. So they just want one organization to look into their various aspects. So that's where ESCOs are very important, and there's a lot of push from the government to bring about establishing a lot of ESCOs in India. So one specific example is a partial risk guarantee fund, where SIGBI is the organization which is managing this fund. So this is funded from the Global Environment Facility through the World Bank and Clean Tech Technology Fund. There's an amount of money which is given to SIGBI, and with the support of ESL and BEE, they will you know, distribute the money to participating financial institutions or lenders. Like these could be either banks or non-banking financial institutions, and the ESCO and the host, right? So they'll deal with the ESCO and the host, and through a performance contract, the entire thing is arranged. So we are working in one of the projects here. So these are the key stakeholders. So here you have the host or the project owner will talk to the ESCO through an energy performance contract. And in turn, the ESCO will talk to the banks or the financial institutions to arrange for the loan. And then the guarantee to the ESCOs is given by the partial risk sharing facility funded by through the SBI, sorry, through SIDBI. The guarantee is given because in some cases the ESCOs are not being paid by the end-use industries because of certain issues, and to safeguard their interest, the PSRF guarantee is given. So this we spoke about typically the various ESCO models that are available. Share and guarantee we spoke. Deemed savings. Deemed savings is basically if you're not able to measure the energy saving. So based on certain assumptions and mutually agreed terms, these savings and MNV is being considered. So these I'll just cover. So for this PSRF, right now it's covered for all the industries, and basically for the small and medium scale kind of industries. Even though large industries can participate, but the guarantee is not provided for large industries. So 75% of the project cost should be towards the energy efficiency projects, and the guarantee is about 75% of the loan amount. That means like 25% the industry or the ESCO has to provide, whereas 75% of the loan amount they'll provide. And up to 15 crore per project can be given as a loan amount. Typically, they are looking at about 5-year loan tenure, or the 5 years, or the loan tenure, which is the guarantee tenure. So these are certain banks which are being provided for PSR projects that already happened right now, and the guarantee value that is being given, and the sectors typically, like what are the sectors which are utilizing this funding is also given in this particular slide. Yeah, so now I'll just quickly cover the real time. We just have 10 minutes or so. So one of the important aspects is real-time data analytics, where even though we do a lot of these energy efficiency projects, now industries are going in for data-based kind of an approach. So the energy management per se, like the current approach is more, depends on static audits or periodic audits. So they do once in 6 months, or they do it say once every 3 years, like PAT, or maybe once a year. So what happens is because of this, they'll get only a snapshot view during that period of time, and it is not a continuous process. They don't get data on a continuous process, and they do a lot of implementation one time, but they don't kind of monitor it for a period of time. So because of that, when we saw that graph where the consumption again increases, right? So that is the reason why that is really happening, because it's more static procedures. Whereas the future approach would be more on a continuous monitoring kind of a basis, where you take real-time decisions immediately. So this will include, tracking real-time data points. So when you are measuring something like a flue gas oxygen percentage using a flue gas analyzer at one point of time, the future approach would be, putting in an oxygen sensor, or this is already happening in the industry, and then you use that as a feedback loop to control the FD fan airflow. Right. So this happens automatically in real time, so that the savings are being achieved. or it could be putting in energy meters across the various departments of the plant and continuously monitoring it. And if there is any deviation, then it sends out an alarm to track and help in improvements. So that this is where real-time data is one important aspect that is being talked about in the industry right now. So here you see the graph on energy efficiency. When you have a managed environment, the energy efficiency keeps on improving. That means you get better and better. But in an unmanaged environment, it drops further. And that is where that same graph that we saw before, where this increases, you recommission again, it drops, energy consumption level drops, then you keep on increasing. Uh, uh, so, uh, so that is where, when you have continuous commissioning, it kind of, you'll be able to kind of continuously sustain it at a lower level bandwidth. And for this to happen, you need a lot of instrumentation in place. And how do you, retrieve data secured and a lot of adequacy. You have to do a lot of statistical data, variations or analytics to bring about insights for the equipment, and also measurement and verification, which is important. So that is why, like you see here, a lot of data which is available in any of the plants, but they're not able to utilize it properly. So you have a lot of data in, say, BMS, SCADA, utility, metering. You have different data format, books, or commissioning documents, protocols. They also have a lot of smart devices or efficient meters that are there, but they're not utilizing the data on how to turn that data into useful information. And that is where analytics plays a big role in terms of how you turn these operational and historical data into actionable information, right, with minimal intervention. So you need not have too much of efforts to find out insights from that. And that is where we kind of do this on a continuous basis: measure, monitor, analyze, and act and decide upon it immediately instead of waiting for a period of time. So this we already spoke about. So typically a procedure to perform a real-time data analytics, what you need is acquisition layer. So what they call is acquisition layer. So these acquisition is what are the parameters you need to measure and what is available at site. So if it is not available, then you have to install the sensor, the field instruments, which are there. And some of the data would already come to your DCS or SCADA-based systems. Then you should have a transport layer to transfer these data or these parameters onto the application layer. So the transport layer will have something like Ethernet switches or routers. And the application layer will have a dedicated database, analytics engine, or data visualization tools. And also, it will convert these sensor data into various trends, charts, and reports, so that you can take action. So whenever there's a deviation, then automatically there'll be a message or an email which will be sent to the operator, so that you'll take immediate action for that. So this is a typical solution architecture where you have, say, electrical meters and field instruments that comes to a data concentrator, uh, and also data from plant systems like DCS will go to the application layer, and then from here it goes to the GUI or the graphical user interface, which will be dashboards and trends and charts that you can see in your system. So this entire thing happens through the cloud. So this is again that typical workflow that happens when you fetch real-time data. You check for quality of the data. You calculate the KPIs or key performance indices. Any degradation insights or process parameter degradation you tend to identify at this point of time. Then to address the degradation, you find out what is the root cause that happened because of why that deviation happens. And once you find the root cause, then the operator recommendations, or the operator will be able to kind of optimize it on a continuous basis. So this is typically how a real-time analytics workflow happens. So this is an example of cement industry again, where you have energy management systems in place, and you get all that data, and then you kind of put all the KPIs. For example, kilocal per kg of cement or clinker. What is the capacity utilization? The process instrumentations are in place. Is it a variable feed or a constant feed? What kind of material for rationalization that can be done. So all this could be kind of tuned accordingly based on the requirements through the energy management system or through an IoT based solution. Yeah, just a couple of slides to complete. Uh, So future technological advancements here from the UNETI report from the government, right? So here they talk about UNETI is basically unlocking national energy efficiency. Here the government is actually looking at a long-term strategy till 2031, where they are from an overall energy efficiency and energy consumption angle perspective. What are the trends that would happen? These most of them are starting to happen right now. So what are the areas like the objectives are basically to bring a global decarbonization drive or reducing the carbon dioxide emissions and shift towards decentralization. So that will not be a combined overall system where you generate from somewhere and then you bring it over a large distance. It will be more decentralized, and there will be a lot of disruptive and innovative technologies advancements that will happen. And Revention's focus on energy efficiency. Efficiency is one aspect that will always be there, and also vision of an interconnected world. So there'll be a lot of interconnection that will happen with various technologies, with various systems, and also industries. And that is where between 2017 and 2022, there are a lot of activities happening. Especially, we spoke about PAT, energy efficient home appliances. So here, there are a lot of these new equipments that are already available with 5-star ratings. And street lighting requirements. You have CCMS for street lighting, automated control strategies, and SCADA street lighting, and solar pumps in agriculture, and energy improvements in agricultural municipal pumps that are happening right now. So the trend will slowly shift to Industry 4.0, that will bring about a lot of machine learning and artificial intelligence into production processes, renewable integration into industrial and MSME. So a lot of renewable integration that will happen. EV and EV charging infrastructure is one aspect that is being spoken about, and there's a lot of pilot projects that are happening. And in the future, this is going to be one important area that we look at. Smart meters and fuel efficiency norms, which will become more stringent and stringent. Right now, the Bharat standards, if you see, it's being made more stringent, and also electrification of the rail system. IoT in appliances is one important aspect. In 2017, it will be more of district heating and cooling system, virtual power plants. Virtual power plants are nothing but you every consumer will be able to give a little bit of power to manage the overall grid situation. It's not that you have to build new power plants to generate power. Net zero energy buildings, where the overall supply demand will be kind of zero. So there'll be new building technologies with IoT and BMS technologies that will happen. And in 2031, they are also speaking about self-driving vehicles, blockchain, artificial intelligence, and industrial process management, and smart home energy management systems. So these are what we are, we tend to look at, and any of the new research activities would happen in these areas. And these are certain areas where the students could look into in terms of improving their knowledge level, so that they'll be able to they'll be industry ready to act in these technologies. So just to give an idea about what is the transformation that is happening overall. Previously, the traditional grid was one way, right? There was a lot of generation devices or generation equipments, be it coal-based power plants or renewable-based power plants. Through the transmission and distribution grid, it goes to the end-use customers. But right now, what we see happening is there are a lot of interaction which is happening between the end use customers and the generators itself. So, for example, a house which has a solar rooftop can generate power and send it back to the grid. So there's a two-way kind of a connectivity. There's EV charging stations. So whenever EV is charging for an automobile, it charges. But if from the other side, if there's no charging, right, from the battery, you can take it back to the grid. So there are a lot of these interactions which will happen in the near future, which has to be secure, predictable, and reliable. And there'll be a lot of new technologies like battery energy storage systems. About megawatt scale batteries and microgrids, which will be integrated with the grid. So overall, this brings about an transformational change in the energy efficiency and and technologies. So that is where like we're talking about dynamic and real-time energy management. That will be an important factor, uh, which uh, which is required. So yeah, I think I've come to an end. So with that, I kind of conclude. If you have any questions, we could
Yes.
discuss. Yeah.
Yes. Sir, it was a great session. You have brought so many new things that faculty will get benefit of energy conservation, energy efficiency. Even the PAT schemes are very important and should be that different schemes. Any questions? You can put on the chat box also or WhatsApp group. Sir, here we can
Questions,
do some
just you can
project
ask.
under CDB also. CDB also.
So is it?
Because near to our institute, textile mill is there, textile process units are there, different textile units are, power looms are there. We can do some energy efficiency project through CDB also.
Yes, we can, sir. Yeah. So if you can, we can always you can discuss with them, and you can get back to us, maybe to me or Shravan, so that we can take it further. Only thing they need not invest anything, so we can get the funding done through CA or through PFIs, and we can implement projects to them. Yeah.
Already I had a word with that someone just to share me the questionnaire. So the data which you need for the further processing, that will share with you. Okay.
Right, sir. Right.
Yes. Thank you. Thanks. Yes.